All right, so chapter 9, section 1 is called Linear and Nonlinear Systems of Equations. So linear meaning it would be an x to the first and a y to the first. Nonlinear meaning one of those could be squared or raised to the third power, something like that. Okay, so it would not be a line. So when you're solving using substitution, which is the first method we're going to cover, you're going to get two equations with two variables. That's what a systems looks like. And you're going to pick and solve either equation, it doesn't matter which one you solve, for either variable, also doesn't matter which one you solve. And then you're going to plug what you get for solving from that into the other equation in place of that variable. You'll solve for the remaining variable, you'll be down to just one at that point, and then you'll plug back in to solve for the remaining one. The answers to these are going to be an x and a y. They'll go in x, comma, y coordinate. So if it was 2, 3, it would be 2, comma 3, 2, negative 3, 2, comma negative 3, something like that. But that's how you'll provide your answers, not x equals y equals, but as an actual coordinate. So there are special cases with substitution, okay? There's two actually. One is all real numbers and one is no solution. The no solution on a quadratic will happen when you try to square with the negative number. But the no solution on two lines happen if both variables cancel out. And what's left is false. If that happens, there's no solution. So that would look like, it would help if I could spell, sorry. If the x and y both cancel and I end up with something like y, 0 equals 3. Obviously, that's a false statement. So if both variables cancel out, what's left is false, that's no solution. If both variables cancel out and what's left is true, then it's all real numbers. So like 0 equals 0, true statement, okay? And that would be all real numbers. So those are the special cases with substitution. The variables will literally cancel out. True statement, all real numbers, false statement, no solution. When you do it graphically, you'll see them not overlap. It would be parallel lines or perpendicular, or the same line. All right, so we'll start pretty easy. Sometimes it's just one step. Sometimes they're already even solved for a variable. But if you look at number 1, okay, I can solve for either x or y, and I can either solve the top or the bottom. And again, sometimes it's going to be obvious which one's easier than the other, and sometimes it's basically the same no matter what you pick. So let's just say we pick the top and then pick a variable to solve for.
Y.
Sure. So if I want to solve this for y, I'm going to subtract the x. And I get y equals 4 minus x. Again, we could have done either equation and we could have done either variable. So then I'm going to take what y equals from that one and plug it in the place of y in the second one. And I get x minus, I'm going to put the parentheses in this time to remind me that that negative goes to both. So I get x minus 4 plus x equals 2. X plus x is 2x minus 4 equals 2. And then just solve. So add the 4. 2x equals 6 and divide by 2. And x is 3. Yep. Yes, so for now you're doing substitution. Then we're going to do elimination. And then you'll get to choose. And we're going to do graphing too. But there are times when you'll get to choose and there'll be times where it says solve using substitution or solve using elimination. So for now, just pretend you don't know it yet. And then I'm going to take and plug that back in. Now I have lots of choices here. I could plug it back into the initial first one, plug it back into the initial second one, or plug it back into the one we already solved for y because that's what we're looking for, which is usually the easiest option. So y would equal 4 minus 3 and y equals 1. And then my answer goes 3, comma 1. Order is important, obviously, because in a coordinate, the x always goes first. Easy stuff, right? These can all be checked, so I can take those two and I can plug them into either of the original ones, and the left side should equal the right side. So with extra time, you should be able to check these two. All right, go to 2. Which one is easier to isolate a variable? The first one for sure. On the bottom, I'd have to move and then divide. And which variable do you want to solve for?
X.
Okay, so we're going to add the y. And I get x equals y. So now in the place of the x on the second equation goes what we just solved for. Y goes there, so it'd be 5 times y minus 3 times y equals 6. 2y equals 6. Divide by 2. And y is 3. Yep.
Could you put x in the place of y?
Sure. Yeah, because it's x equals y, it doesn't matter. And then I'm going to take and plug that back in. Again, I can plug it back into either of the first original ones, or because I already know x equals y, I can also say that x equals 3. And this would be 3, comma 3. Yep.
So after we solve in the first equation and then move to the second one, to check the second one, we can plug it back into either equation?
Correct.
Okay, thank you.
You're welcome. Questions on that one? All right. Then obviously they get more complicated. So these are word problems involving interest, okay? They can also do word problems involving money or coins or anything like that. Like there's geometric word problems where you have to set up a systems of equations. So there's a lot of different kinds, and standardized tests love this stuff. This says, the first one says, a total of $12,000 is invested in 2 funds paying 5% and 3% simple interest. The total annual interest is $500. How much is invested at each rate? So for most of these, they're going to give you like a total amount invested. So I want to set up an X and a Y for each of the 2 different accounts. So in this case, you've got a 5% and a 3%. So if I say that X equals my 5% account and Y equals my 3% account, you've set up your variables. You can make them whatever you want to be as long as you're consistent. And then when it says total, that means all the money I invested in 5% plus all the money I invested at 3%, right? So I can say X plus Y equals 12,000. The total amount of money invested. The other piece of information it gives you is how much money was earned, how much interest was earned on that. You find interest by multiplying by the percent you're earning. So I have to take that 5% and convert it to decimal. How do you convert from percent to decimal?
2 places left.
2 places left. So this is the same thing as 0.05. And 3% is the same thing as 0.03. So I'm going to multiply that 0.05 times all the money I invested in that one, which is X. So 0.05X. Plus the 0.03 times all the money invested in the Y one, so 0.03Y, and set that equal to the interest earned, which is 500. With me so far? So you have choices here. You can use substitution, so I can move the X or the Y to the other side. I would say the top one is easier to use, okay, and then plug it in. You can also eliminate your decimals. So if I wanted to get rid of the 0.05 and the 0.03, I'd have to multiply everything in that equation by 100 because I want to move it 2 zeros. So if I do that, I end up with 5x plus 3y equals, I'm adding the 2 zeros onto the other side of the equal sign as well. Now you're not dealing with decimals, so that's the perk. You don't have to do that. But if you're awful at decimals, and or don't have a calculator because a calculator makes it easier, then you can get rid of them. Yep.
Would we get a calculator for this test?
It depends, honestly, on the level of question, which we haven't done yet. All right, so then X, and if you do, it won't be a graphing one. It would have to be scientific. Yeah. The X plus Y, so let's say I just want to solve this one. I'm going to actually go back and look at the wording on my word problem. This time it says how much is invested at each, which means I want to solve for X and Y. Sometimes it will say how much is invested at the 5% account. And so in that case, I only want to solve for Y, so I would eliminate the X. Okay, so you always want to help yourself out a little bit by knowing what the end goal is. Here it's to find both. So I'm going to find X and Y, so it doesn't really matter which one I solve for at the top. So if I take that first equation and I subtract the Y, I get X equals 12,000 minus Y. And then 12,000 minus Y is going into the X on the second equation. So I get 5 times 12,000 minus y plus 3y equals 50,000. All right, then I'm going to distribute the 5 in. So 3 zeros, 4 zeros, and a 6. So 60,000 minus 5y plus 3y equals 50,000. And I'd get 60,000 minus 2y equals 50,000. Subtract the 60,000. I'll see you later, S1. Negative 2y equals negative 10,000. And then divide both sides by negative 2. And y equals 5,000. And the y represented how much, which percent? The 3%. So we invested $5,000 at 3%. How do I figure out how much was invested at 5%? You could plug it back in here, right? I could plug it back in here. I could, if I was really crazy, plug it back in here, right? Or just do 12,000 minus the 5,000, or 7,000. So 7,000 was invested at 5%.
So, just getting this straight, the first equation that you did was because the total money was invested in 5,000, so the account X and Y, total amount of money equals 12,000. And in the bottom equation, you're trying to find how much interest. What do you mean by the rate, though?
The rate is the percent that you're earning. So like if you're earning 5% on the money, that's the rate, interest rate. All right, so 4 says a total of 25,000 is invested in 2 funds, paying 6.5% and 8.5% simple interest. The total annual interest is 2,000. How much is invested at each rate? So what's one of the equations? What's X? Okay, so make sure you know which one's which. So you set up X is 6.5 and Y is 8.5. Yep. It doesn't matter. It literally doesn't matter. As long as you know. I could have made it A and B. I could have reversed that order. As long as at the end I know which one's which. Yep. All right, so then we said X plus Y equals 25,000 because the amount of money invested in each of those is 25,000. What's the next equation?
0.65x plus 0.085y.
God bless you. Good. Move your decimal 2 places left, and it looks like that. I'm going to keep the decimal this time just so that we can practice both ways, but if I wanted to move the decimal, what would I have to multiply by this time? 1,000, right? I'd have to move it 3 places, so it'd have to be 1,000, not 100 like the last time. But I'm going to keep it just so that we can see both. All right, so I'm going to take the top, and I'm going to solve, and it doesn't matter which one I'm going to solve for. So let's just say I solve for X. I'm going to say X equals 25,000 minus Y. Then what X equals is going to get plugged in. So 0.065 times 25,000 minus Y plus 0.085Y equals 2,000. Then I distribute here. So I'm going to multiply. So I'm going to use my calculator because I didn't get rid of those decimals. 1625 minus 0.065y plus 0.085y equals 2,000. Combine your like terms here. 1625 minus, plus 0.025y equals 2,000. I don't know why I put the 5 there. That's not there. It's just 0.02. And then I'm going to subtract the 1625. $375. And then I'm going to divide. $18,750. So just as a reminder, if I had to divide this without a calculator, I'd have to do 375 divided by 0.02, and I have to move this back twice, which means I'd move this back twice. And then it's just 2 into 3, 2 into 17, 2 into 15, 2 into 10, and then the extra 0. So if you had to, without the calculator, just don't forget you gotta move those decimals. So the amount that was Y was our 8.5%. So we invested $18,750 at 8.5%. So to find how much was invested at 6.5, I just subtract it from 25,000. Rodrigo.
Can you zoom in on the blue with the 2 Y?
Okay, so then I get 25,000 minus 18,750, which is 6,250. And that's how much is invested at 6.5%. So here's what else is pretty easy to check on these. If I, in my calculator, do 6,250 times 0.065, because that's how I would multiply the percent. And then I did 18,750 times 0.085, and I add those two together, I should get that 25,000. So 6,250 times 0.065 is 406.25. 18,750 times 0.085 is 1593.75, and if I add those two together, I get that wait, I just did it wrong. Sorry, thank you. 2,000, which matches the total interest, not the 25. Questions? So my answer is this, and again, that was just us checking at the end. You don't have to check it, but it's an easy way to make sure you're right. Okay, now we're gonna get into the nonlinear systems. Nonlinear, again, means that something's got an exponent. So it could be x squared, x to the third, something like that. Whereas up to this point, you could have graphed both those lines where they intersected, would have given you the answer, and they would have both been lines. Now they're not going to both be lines. You might get a line with a parabola or a line with a cubic function, something like that. These can have more than one solution. So if you could picture, like if you thought about it in terms of a graph, if you could picture before, there would have been 2 lines because they only had an x and a y to the first power. There could only be one solution there. But now you're going to get things like parabolas or a line with a parabola. And in that case, you're going to get more than one answer. So in this case, you'd have 2. You don't always get more than one answer. As a matter of fact, if they're turned the other way, you'd get no solution. If it was something like this and this went this way and my parabola went that way, they'd never intersect and you get no solution, okay? So that's why the word can is here. Can have more than one solution. All right, so they'll look like this. Now they're definitely more complicated, right? If I look at the top and the bottom, here's the thing you want to avoid, plugging into the one that's squared, because then you have to expand and FOIL. So I would not solve for the bottom for x and plug it into the one on the top. Did you do that? Yes. You have to expand and FOIL. You can. It's just extra work. Better to not plug in for that one, okay? So look at the top and the bottom, pick a variable, and then solve for it. So which one would be easier to solve for? The y. Does it matter in the top or the bottom? Okay, let's solve in the bottom. So I would want y to be positive. There's 2 ways to do it. Move the y, then move the -1. Or subtract the 2x. And then multiply by -1. Either way, you need to do 2 steps. So I get y equals 1 plus 2x. Now the 1 plus 2x is going in the top in the place of the y. So I get 3x squared plus 4x minus, and that minus is going to go to both terms, so I'm going to keep it in front of the parentheses for now to remind me to distribute. Then I distribute, so 3x squared plus 4x minus 1 minus 2x equals 7.
We solve for y because it just shows it? Or
Because I don't want to have to expand and FOIL.
yeah.
Yeah. Then I get 3x.
When it has the x, is the x squared.
Whichever one is squared is the one I want to avoid solving for. Sometimes you can't help it, but if you can. Oh wait, this combine my like terms here. So 4x minus 2x would be positive 2x, and then minus 1 equals 7. So as soon as I see the x squared and the x, it's my hint I'm going to have to factor. So instead of moving the 1 to the other side, I'm going to move the 7 to the left. And I get 3x squared plus 2x minus 8 equals 0. And we factor. So this is, you can do first times last here. 3 times negative 8 is what?
Negative 24.
Good. Factors of negative 24 that sum to positive 2.
6 and negative 4.
Good. Plug those in. And then factor by grouping. So take out a 3x. Take out a negative 4. Take out the x plus 2. And I get 3x minus 4 left. Now I got to split and solve. And I get x equals negative 2. 3x would equal 4. And x would equal 4/3. Now that means there's 2 x's, which means that is 2 coordinate points. So I'm going to have to find 2 y's. So I'm going to take the one I solved for a y. Again, I could have done it in either of them, but I'm going to take the one I solved for y and plug in those x's. So y equals 1 plus 2 times negative 2, and y equals 1 plus 2 times 4/3. So I'd get y equals 1 minus 4, y would equal negative 3. That goes with the negative 2, so make sure you put them with the right match. And then y equals 1 plus 2 times 4/3 is 8/3. 1 is 3/3. So that becomes 11/3. You could totally make it a mixed number if you want to, or you could leave it improper, as long as it's simplified. Questions on that one? So again, if you look at your equations at the beginning, there was an x squared, and that means that's a parabola, and then the one on the bottom is not squared, so that's a line. So this was the cross-section of a parabola and a line, which can be nothing, can be 1, or can be 2, which is what this case was. If I were to put this on a graph and calculator, which we'll get to graphing eventually, that's the next section, you would see them intersect at those 2 points. So how do we start it, or how can we start it, because there's more than one way?
Solve the top equation.
4.
Y.
Okay, so I'm going to get y equals 5 plus 2x. Then I'm going to take that, and I'm going to plug it in the second equation in place of the y. X squared minus, because that minus is going to go to both. Distribute the minus. X squared plus x minus 5 equals 1. And then the x squared and the x tell me, get it to one side and factor.
We can rearrange it, right?
Sure. What are the factors of negative 6 that sum to positive 1? Positive 3, negative 2, good, and then split and solve. And there's 2 x values, so there's going to be 2 y values. Now I'm going to plug those in. So I'm going to take the one that's solved for y, 5 plus 2 times 2, y equals 5 plus 4, and y equals 9. That goes with the 2. And then y equals 5 plus 2 times negative 3, y equals 5 minus 6, and y equals negative 1. What are you going to do? Solve for y in the top. So y equals 4 plus x. Take that, plug it into the y. X squared plus 4 plus x equals 3. Subtract the 3 and rearrange. X squared plus x plus 1 equals 0. What are the factors of 1 that sum to 1? Nothing. Trick question. Yuck. What do we do when we can't factor? Oh, yeah. A is 1. B is 1. C is 1. Negative b plus and minus the square root of b squared minus 4 times a times c all over 2 times a. Negative 1 plus and minus the square root of 1 minus 4 over 2. Okay, negative 1 plus and minus the square root of negative 3 over 2. Good. You cannot square root a negative number. Okay, if that was a positive number underneath, I would keep going, okay? But you cannot square root a negative number, which means there is no real solution here. You could put no solution, you could put no, does not exist, okay? I think on WebAssign it's the DNE, yeah.
For these types of questions, we can't graph the imaginary numbers, right?
Correct.
Okay.
Right, so like if you went and actually put that on a graph, if we have time, we'll do it. If you went and put that on a graph, you would see them never intersect.
You don't want us to put the solution as an imaginary number?
Nope.
Just no?
You're looking for all real solutions for these. Yep. All right, so how many of you solved the top for y? Okay. All right, so I would have probably done the same thing. If you solve for x, you end up dividing at the end, which is possible. But at least in the top, the y is already isolated. So and that you can do that two ways. You can either move the 2x over, so it'd be negative y equals negative 3 minus 2x, and then multiply by negative 1, so y is 3 plus 2x. And you could switch that order. If you're used to the x being at the front, doesn't matter, or you could keep it that way. Then I'm going to take that and I'm going to plug it into the y in the second equation. Now this time we can't avoid the expanding and foiling, so it's going to get plugged in. I have to expand this before I can distribute that negative. So I'm going to get 2x squared plus 4x minus, the shortcut is square the first, square the last, and then double the product. So that would be 6x times 2, positive 12x. Oh, this should be x squared, sorry. Then I would distribute the negative. 2x squared plus 4x minus 9 minus 12x minus 4x squared equals 0. And now I'm going to combine my like terms. So negative 2x squared minus 8x minus 9 equals 0. Then I'm going to multiply negative 2 times negative 9, which is a positive 18. Are there factors of positive 18 that sum to negative 8? No, which means? Quadratic formula again. A equals negative 2, B equals negative 8, C equals negative 9. Yep. No. That's fine. Like you could have multiplied everything by negative 1 and it would be fine. So then I'd get negative 8, so 8 plus and minus the square root of negative 8 squared minus 4 times negative 2 times negative 9, all over 2 times negative 2. 8 plus and minus the square root of 64, this is 8, positive 8 times negative 9, and that's negative 72. I don't even need to keep going. As soon as you see that that's going to be negative underneath, it's no solution. WebAssign, you actually write the word no solution, like the whole thing, and no space in between. It tells you in the instructions, but that's what it would be. If it's a negative underneath the square root. Yeah, if there's a negative under a square root, you can't do it. Yeah.
Can you keep it negative 4 when you multiply it? Or do you multiply 4? Do you multiply 4AC together and then subtract what you get?
Yeah. Yeah, so this part, so I'd multiply that out first.
Multiply with the sign.
It doesn't matter. You can multiply it without. That would be a positive 72, and then you're subtracting that. So you're still at a minus. Like if I do it without the sign, this ends up being positive 72, but it's still minus that then. And it'd still be negative.
Oh,
You did both, right?
yeah.
Yeah. Questions? Okay, we're going to hold off on that last slide, but we're going to talk about how I would check these using a graphing calculator. The homework actually says solve and then check it graphically. So I'm just going to show you how to do it. You're not expected to graph these by hand yet, and on a test you wouldn't have a graphing calculator. It is simply just a tool to check it. And hello, standardized tests allow you to use a graphing calculator. So if you get a systems of equation and it's easy to solve for the variable, then it's obviously going to be way easier to use those graphing calculators to find your solution. It's not like cheating. You're allowed to do that, okay? So you can do that. I'm going to pick a linear one, and then we're going to pick the nonlinear one.
We do have a top 10.
Okay, so I grabbed example 1. The first thing you have to do is you'd have to solve for y. We already did it in the top, so I can enter this in the first y equals on the calculator. But I also have to take the bottom one and solve for y. So x minus y equals 2. Excuse me. I can move the x. Negative y equals 2 minus x, and then y would equal negative 2 plus x. So now I'm going to enter those two, y equals 4 minus x, and y equals negative 2 plus x, on the graphing utility underneath your y equals tab. So hit the y equals, and the order doesn't matter. I could do whichever one first, but 4 minus x, and then negative 2 plus x. And then I hit graph. Okay, so I went to the y equals, and I'm going to type in each of those. So y equals 4 minus, the x is this button, and then y equals negative 2 plus x. Enter, and then I hit graph, and it's going to graph those two lines. And then to find the intersection, I go second trace, and that goes to that calculate menu. And I want to go to 5 because that's intersect. And on the bottom, it asks you first curve. And as long as that flashy thing is on one of your curves, you're good. If it's not arrow, like give the arrow until it's on one of those lines and hit enter. And then it will jump to the second one. And yes, that's the second one. So hit enter. And then it says guess. And I'm ready for it to guess. So I hit enter again. And it says intersection on the bottom, 3, 1. Your other option is your app, like the EduCalc Classic. That app will also do the same thing. All right, so we went to the graphing utility. We hit the graph. We went to the equations tab, and we typed in the equations, and then you hit graph, and it takes you to this screen, and then you double tap your screen, and this little box shows up, and you're going to pick find intersections, and then you have to tap where they intersect, and it will give you the coordinate point at the top. All right, we're going to do this with one of the quadratic ones, or the nonlinear. Okay, so 5, and this is, to be honest, sometimes these are more work than they're worth. Okay, so if it says to graph, it says to check your answer graphically, you don't have to. It is simply just to help you out. If I want to graph these, I have to solve each of them for y. So I already solved the bottom for y. That's one equation. But now I have to solve the top. So I'm going to get 3x squared plus 4x minus y equals 7. I can move the y and then move the 7, and I'd get y equals 3x squared plus 4x minus 7. And now I have to enter in both of those. So on the graphing calculator, I go y equals, and the first one is this one, 1 plus 2x. And the second one is 3x squared plus 4x minus 7, and then I hit graph. So this time I got a parabola, which makes sense because it was squared. I got a parabola and a line. To find the intersections, I'm going to hit second trace, and I'm gonna go to 5, which is intersect. And it says first curve, and it's on the blue line, that's fine. It doesn't matter which one's first and which one's second. Second curve, and it's on the parabola. I'm gonna hit enter, and it says guess. And it's gonna take me to the first one, which is 1.3, or 4/3, and 3.66, which is the 11/3. Now, if I wanna go to the other intersection, I have to go closer to that one than the one we were just on. So I'm gonna repeat the process. Intersect. I actually think if you hit enter, hang on. Nope, I have to go back all the way. Okay, so I'm gonna go to intersect. This time I'm gonna go closer to that intersection, first curve, and then it brings me there. And now it's gonna bring me to that one on the left, and that's the -2, -3. So again, at this point, we're just doing this to check, okay? If that totally confused you, don't do it. It's just to check.